Good morning, everyone, and welcome to today's live talk. And today we're joined by STEM Ambassador Harriet, who is a space systems engineer at Airbus, and to hear about her Airbus extensive work in the space industry, and to hear about her career with Airbus so far, from a work experience student to a satellite payload designer. So welcome everyone to today's talk. You'll hear from Harriet in just 1 second, but in the meantime, just to let you know how this will work today, Harriet's going to talk about her journey, her career journey, and then at the end there'll be an opportunity to ask questions. Please use the Q&A chat, what you'll see on screen now, where you can enter any questions you'd like, and we'll get as many answers as possible at the end of the talk. So without further ado, I'll hand straight over to Harriet.
Good morning, everyone. Thank you there for the introduction. So as was mentioned, my name is Harriet Gamble. I work for Airbus Defence and Space based in Portsmouth, and I'm here to talk to you today about how Airbus put the space in aerospace. So I thought I'd start with a sort of personal introduction, a bit about me. So I've been working at Airbus full-time since 2018. But I actually started back before then. I've been involved in the company right the way through, from work experience all the way up to now, where I'm a lead mechanical engineer for one of our major projects on satellite design. And I'll give you a bit more information about that later. I've always been interested in space, like the idea of space exploration, the history of missions to the moon. It's always fascinated me. So I've really been lucky to find a career where I get to combine that passion and interest in space with my love for designing and making things. So I did a degree in aerospace engineering at the University of Bath, and that was kind of the launch point for my career so far. Now, I'll tell you a little bit more about how I got to my career later, but first I wanted to tell you a bit about Airbus and what it is we do. So most of you are probably aware that Airbus design and build really large aircraft, commercial aircraft, things like the A320 or the A380. But what a lot of people don't realise is we actually have 3 different divisions. So that's the commercial aircraft side of the business, defence and space, and also helicopters. And we're actually Europe's largest company within the space sector. So as much as we're mostly based in Europe, with our home countries being the UK, France, Germany and Spain, we're also based in lots of other locations across the globe. We have over 134,000 employees, and that's over 140 nationalities, so a huge variety of people. And that means that Airbus has got some of the best minds working on designing and developing all of their new products. So seeing as today we're talking about the space sector, I thought I'd dive a bit deeper into what the defence and space area of our business do. So that can kind of be split down into 4 further groups. The first one being the military aircraft. So some of that's things like our combat aircraft, things like Eurofighter, but also the A400M, you might have seen, was involved in quite a lot of missions during COVID and providing support and things and medical evacuation there. We've also got space systems. That's the area I work in, so I'll tell you a bit more detail about that one and the different sort of aspects of projects involved within space systems. We've also got communications, intelligence and security. So a lot of that is the cyber security, military communications, and looking at the future of how cyber is going to develop and how we're going to help keep that secure. And finally, we've got unmanned aerial systems. So that's sometimes called UAS, or unmanned aerial vehicles. UAVs is probably the acronym you probably would recognise more. And that can be used for like airborne intelligence, or you might kind of think of it sort of as spy stuff within the military aspect. But it can also be used for mobile communications, providing internet in areas that perhaps have an internet outage. And again, you can be looking at combat missions. So I thought, as opposed to giving you a summary of the space system side of the business, I'd talk to you about some of our most interesting projects, some of our really big highlights. And that kind of goes through all of the different areas that we do. So I thought I'd start with human spaceflight. And this is our sort of headline project at the moment. which is for the NASA Orion space mission. So this is going back to the moon, which I think is super cool. And previously, this has all been done by NASA, but this time the European Space Agency is the first sort of non-American aspect where they're providing mission critical technology. So ESA is in charge of what's called the European Service Module. So that's the part of the Orion that provides water and oxygen, as well as keeping the spacecraft at the right temperature, which is really important when we've got humans on board, and keeping it on course so that it's heading in the right route to do its orbits around the moon, and also for allowing people to land on the moon. And whilst this is being headed by the European Space Agency, Airbus Defence and Space, based in Bremen in Germany, are actually the team who are leading the design and development of this. So it's being built by Airbus, which is super cool. Along with our sort of human spaceflight aspects, we've also got space exploration. So Airbus have a really long history with sending different probes and satellites out across our galaxy to find out more about different planets. But this one here, Solar Orbiter, is actually going to look at our sun. So Solar Orbiter is sometimes known as SOLO, and it was launched in 2020. And so far it's travelled over 100 million kilometres to get closer to our sun. So it's gone there to have a better look at our solar pole regions. So a bit like the North and the South Pole on Earth, looking at these polar regions of the sun. But as you can imagine, the sun is really super hot. And the closer you get to it, the hotter things get. So you'll be able to see here, Solar Orbiter has got like a big buffer on the front of it facing the sun. And that is to try and keep all of our electronics safe, because the outside of it that's facing the sun is at over 600 degrees centigrade. So that's required new materials to be developed, new designs of how you combine those materials and keep our electronics safe. And what I think is super cool about developing space technology, technology for space and engineering for space, is that it has applications on Earth. So finding out how we can manage to keep these things cool can also help us with products on Earth, and often those are things within the medical domain. So that's a really nice, rewarding sort of side aspect of working and designing things for space. This is one of my favourites. It's looking for life on Mars. So this is the Rosalind Franklin rover, and she has been designed and built by Airbus in Stevenage, which is near London. And this is going to be the first European rover on Mars. And it has to be completely autonomous. So if you think about how long it takes for you to send a signal all the way to Mars, your rover receive it, and then for it to send its data back. So like if it's got a camera on it to know where it is, that round trip takes 20 minutes. So if you suddenly come across an obstacle, you don't have time to tell the rover which way to turn, how to avoid the obstacle. So the Rosalind Franklin rover actually does its own thinking. It's learned how to look at the terrain, plan where to go, it maps its own routes. And the way we do that is by actually practicing with it. And we have what's known as the Mars Yard at the Stevenage Airbus site. So it's like a giant sandpit. It's literally set up to look like the terrain on Mars. And the rover can practice navigating that and how we control it and what signals we need. And the rover was also built in Stevenage, and we have a huge, what we call the bio clean room. So you can see all of the people here in the picture are all wearing coveralls, and their hair and their beards and everything are covered. And this is to make sure that the rover doesn't get any contamination, because when we're looking for life on Mars, we have to be very careful that we don't accidentally take some of our own life from planet Earth there and confuse things. So the BioClean Room is a fantastic piece of technology in itself, and it allows Airbus to work on really cool missions like this one. The next part of sort of the space systems family is our communication satellites. So this is probably the bit that makes the most obvious difference to our life on Earth day to day. So telecommunication satellites provide television, telephones, radio, the internet, and military communications all across the globe. So most of these satellites are in what we call geostationary orbit. So you might be familiar with that, you might not, but the concept is, because the Earth is rotating, if you put a satellite far enough away from it, then it rotates at the same speed as Earth is rotating. So it effectively hovers over the same bit of ground. And to do that, it has to be at 22,300 miles above Earth's equator. So they're quite a long way away. And at the moment, Airbus are developing a new communication satellite product called OneSat. And this is quite a change for the industry, actually. Traditionally, these satellites were designed and built, and they would be in orbit for around 15 years. But on the ground, before you launched it, you had to decide what area you wanted to cover of the globe, what frequencies you were sending your transmissions at, what the purpose of it was. And OneSat is all reprogrammable in orbit. So you can launch it. It will still last for a lot of years in orbit, but you can change its function whilst it's up there. And that's really great, because media at the moment is changing so quickly. It means we don't have to forecast what we're going to need in 15 years' time. We can just adjust it as and when things change. And the final bit of the Space Systems product family is our Earth observation satellites. So this is the bit that I'm involved in. And it does include spy satellites, but most of it is actually for environmental monitoring. So that can be looking at deforestation, our polar ice caps with global warming. They can be used to look at things like, is the ground moving? You can send the satellite around once and it takes a picture and knows how high the ground is. And it can go around again and take another image and see the difference in height. And that's called interferometry. And from that, you will actually find that the ground moves by a few centimeters before you might have an earthquake or a volcanic eruption. And it means that we can actually inform emergency services and help get people evacuated out of areas. So for me, whilst the communication satellites are the bit that obviously makes a difference, you receive your internet, you know if you've got it, these Earth observation satellites can have a huge impact in saving lives. And also, you know, it's improving our understanding of our ecosystem and looking forward to the future. So that's really, really important for me. And it's great to be involved in something that you feel like it matters. So one of the biggest programs of satellites is run by the European Space Agency, and it's called Copernicus. And it has more than 30 different Earth observation satellites in it. They all do different things. Some of them are looking at weather patterns, some of them are looking at ocean currents, all collecting tons of data. And each of these satellites is built by various companies, but a lot of them have Airbus involvement. We either design the whole satellite or we design the payload, which is like, on a satellite you have like a satellite body which provides your attitude control, how you can roll and move your satellite around and point it, all of your power systems, and then you have your instruments. So that's the bit that does the collecting of the data. So that might be a camera, it could be a sensor of some sort, and Airbus is normally involved in one part or the other on most of the Copernicus missions. And what's really great, I think, about these Copernicus missions is that all of the data that's collected from these satellites is free for the public to use. So that means any scientists can use that data to help with their studies. So I've told you a bit about what Airbus do generally, all of our space systems aspects, but what about my work specifically? As I said earlier, I generally work on Earth observation satellites, and I do the mechanical and thermal designs for the payloads, so for these instruments, particularly what we call synthetic aperture radar instruments. So a bit like a camera, it takes images, but you take the images using microwaves. Sounds a bit weird, but with a camera, you have light from the sun, it hits the ground, it bounces back into your camera sensor. With this, the satellite transmits out microwaves, they hit the ground, but they're really, really low energy, so they don't do any damage at all. And then it goes back into space and is received again by the satellite. And from that, we can build a picture. So the picture you see in the bottom left corner there, the one strip through the middle that looks quite bright, that is actually an image taken with a SAR, a synthetic aperture radar, overlaid on Google Maps with an optical image. So you can see how much they can look like photos. But they're great for using for mapping, for disaster response if you're in areas with bad weather. So really cool technology. My main project at the moment is called Roselle, and it is a Copernicus satellite for the European Space Agency, and it's going to be looking at forest management and monitoring of geohazards. It's also there to help with farming and working out when's the best time to plant crops. And that can help with the situation with global hunger. So it's an Airbus payload design, and it has a huge SAR antenna. It's 3.6 meters by 11 meters. And in order to get that into space, you have to think about how you fold it up. It can be a bit like origami. So lots of problem solving needed there. I also had the opportunity to work on NovaSAR, which is a much smaller SAR, around 2 meters by 1 meter for the UK Space Agency. And it's having a look at how we can make these satellites smaller and cheaper, so we could have more of them and collect more data. And that launched in 2018. And it's still up there collecting really cool images now. One of the nice things about working for a big company like Airbus is that alongside having sort of a main area I work on, you can have some other side bits. So I also had the opportunity to spend 6 months working on Zephyr. So this is a UAV. It's an unmanned aircraft, but it's got a 25-meter wingspan, so it's pretty huge, but it weighs less than 75 kilos, so less than a typical adult. On top of that, for being pretty cool, it flies at 70,000 feet. So that's about double the height that a commercial aircraft flies at. So we call them pseudo satellites because they're almost on the edge of space. And the longest flight time for one of these is 64 days. And we're expecting them to be able to fly for 3 to 6 months at a time once they're fully up in production. And I had an opportunity to help with the payloads on this. So it takes a payload, a bit like a satellite does, but if you want to swap it out, you need to change or improve the technology on your payload. You can just re-land the aircraft, change it out, launch it again. And the launches are sustainable. So you can see in the picture here on the right-hand side that it's actually launched by a team of people. So you run and you throw it as a group of 5 people, a bit like a giant paper airplane. And I actually had a chance to do that whilst I was out working on the project. It's pretty awesome to see. So my role, how did I get here? You know, I can tell you that it's a really cool career, but how do you get into a job like this? So there's first thing to say is there's lots of routes to do it, but I'll tell you a bit about my one. So as I said earlier, I've always been interested in space and outer space, going to space. I'd love to be an astronaut, but I also love engineering and solving problems. And I'll be honest, probably not from quite as much of a young age as that picture is. But from probably about 11 or 12 years old, I think I knew that that's what I'd quite like to get involved in. So I did some work experience when I was at school, and I chose to go and work in what's called a computer-aided design office, a drawing office. And the reason for this is that I liked maths and science at school. I was quite good at them. But what I really enjoyed was designing things. I loved art classes and I loved resistant materials, design technology. But I wasn't very good at drawing, and this work experience showed me that actually there are so many cool tools on your computer, and some of them are free, that you can draw and you can design things, you can send them to 3D printers, and that really got me thinking about the fact that I could use my creativity and design stuff and put it together with the maths and science and become an engineer. So I went on to college and did A-levels. I did maths, further maths, physics and electronics. I enjoyed all of those subjects. The electronics gave me a bit of hands-on work and kind of broke up all of the book studying from the other subjects. My top tip would be, you have to be interested in what you study. Studying is hard work, whether that's for your GCSEs, for college level courses or university. And it's so much easier to do if you like what you're studying. So that's my top tip to everyone. But alongside my time at college, I also did some part-time work to help get a bit of money. And I worked in a factory where we were manufacturing things to go inside trains. And I didn't get to do any design work. I wasn't doing exactly what I wanted to for my future career, but it did teach me a lot about how you have to design things for how you can make them. And it matters how many of them you're going to make as to how you might do the design work. So that's actually been, as much as it was just to help me get a bit of money whilst I was doing my A-levels, it's also been really helpful in my career. So part-time work's really, really useful, especially if you can find something that in some way supports the career that you want to go towards. It doesn't have to be a perfect match, but lots of different skills help. I then decided to go on to do an aerospace engineering degree, which was at the University of Bath. And I chose this degree because the first 2 years were what we call unspecialised. So it was just mechanical engineering. You could then choose after those 2 years to specialise in aerospace or automotive or manufacturing. And at the time, I thought I wanted to work on space stuff. I'd never done it before. So this was a great way to try it all out in the first 2 years and make sure it's what I really wanted to do. I also chose this degree because it offered a year in industry. So that meant that I'd do 2 years studying, 1 year out working and earn some money whilst I did it, and then go back for another 2 years and get a master's degree. And that worked really well for me. And I went and worked for Airbus during my year in industry. So that gave me a fantastic taster of what my future career could be. And it really solidified for me that I wanted to go on and study all of the space modules. That's what I wanted to specialise in. I also did some summer work at Airbus, like a summer internship for 2 months to help fund my studies. And then I joined Airbus as a graduate. So straight out of university, it's a 2-year scheme, and there's some teaching and learning along the way, the opportunity to work in some different areas of the business. And that's how I settled in the Earth Observation Department. So what does my job look like day to day? You can kind of summarise it as design, build, test, launch, but actually that whole process takes a bit longer than you'd expect. So the Roselle project I'm working on at the moment, I started working on in 2019, and it isn't due to launch until 2028. So these really big projects take a long time. So depending at what point we're in on the project, depends on what my day looks like, but often it can involve some of these things. So going and speaking to suppliers. Whenever we're building and designing something, it takes more than just Airbus, lots of other companies involved to help provide us with products and materials. So I'll have lots of time talking to them, visiting their factories and their offices and finding out how we could use their products in our designs. We do what we call mission analysis work. So that can be looking at what orbit the satellite's going to be in, what launcher, what rocket is it going to go on, how much do we have to compact it down to launch it. We do lots of design work, drawing up our ideas. So you can see on my screen here, on my picture, this is some of my design work for part of an antenna, and I've got bits of the antenna all over my desk. So having an opportunity to come up with some designs, make some bits, make some changes, make some new bits, and work out how it's all going to go together. I spend a lot of my time presenting my ideas to our customers. So like on Roselle, our customer is the European Space Agency. So about every 8 weeks, I travelled somewhere in Europe and I present my ideas. That's often like a PowerPoint presentation, a talk, get lots of questions. But we also write lots of documents to show what our designs are like, lots of drawings. And then we get to building our designs, which is great fun. So that is then in one of these clean room facilities, like I was talking about earlier. Everything has to be assembled, you have to test it, make sure all the electronics is working. And then, because I'm a mechanical and thermal engineer, I'm in charge of doing the thermal and the vibration tests. So when something's in orbit, it sees a real range of temperatures, it gets really hot. So we have to practice that on the ground. We put it in like an oven, make sure everything works over lots of temperatures. And we do vibration testing, which simulates launching. So we literally shake the satellite. And sometimes they behave a bit like a jelly, depending how stiff and rigid they are. So it's pretty cool to be involved in all of that testing and finally get to see your designs in reality and know that they're going to go into space. And that's the bit that really gives me a buzz, knowing that stuff that I've worked on and designed, along with a huge team, and it is a huge team, it could be hundreds of people, have come up with this idea and it's reality. It's sat in front of you and you're going to put it into space. That's pretty awesome for me. So that's a bit of a summary about my career, what it's like working at Airbus, some of the stuff we do. as I said earlier, it is just my route into my career in space. There's lots of ways in. Even within Airbus, we take people who are graduates, we take apprentices, we take people who have come out of their military service. And if you want to find out a bit more about those career pathways, you can go to the Airbus website. And if you want to find out a bit more about some of the cool projects Airbus is working on, feel free to have a look on some of our social media. I hope you found that all really interesting, and I'd love to hear what questions anyone's got.
Thank you, Harriet. That was really interesting. Great talk. Fascinating. So we have got some questions that have come through. We've still got time for some more, so please put those questions in the chat. So the first question I've got is, what's the most exciting project you've worked on?
I think the most exciting project is probably the Roselle one, because I've been involved with it for such a long time. I saw it right the way from its early stages and did all of the early work on it. And knowing that it's going to be in orbit for 7 to 10 years and how much data it's going to collect to help the scientific community find out more about Earth, I find that like really cool and exciting.
Okay, so when is the Rosalind Franklin rover planned to go to Mars?
So actually, the Rosalind Franklin rover was due to have already been launched, but there's been some problems to do with the fact it was meant to be on a Russian launcher. That's now changed. So there's got to be some modifications made to the rover and how it mounts in to the launcher. And it's now going to be launched in 2028. So it's a bit of a delay, but we will get it to Mars to collect its data.
Fantastic. Okay. So what are good A-levels to take if you want to work in the space industry?
I think that depends. If you wanted to do a career like I have, engineering, then maths and physics are really important. You have to have those two generally to do an engineering degree or to get on to some of the apprenticeships that require like A-levels for entry. Some of them just need GCSEs, some of them are A-level entry. So maths and physics are key if you want to do engineering. But Airbus also needs people, and the space industry in general, we need scientists. So, you know, if you were someone who was working on something like the Mars rover, but you were interested in geology, you might be the person who's advising them on the Mars rover on what terrain it's going over, how we're going to drill into Mars and collect the samples and things. You need to know all about rocks and the ground. So you'd study different subjects for that. The space industry is just really broad. You know, you can look doing medicine for human space flight, but also you've got loads of supporting roles. Lots and lots of people work within the space industry at Airbus doing things like the finances, the project management, human resources. Building big teams is hard work. So we need lots of people with good people skills to help with that, as well as all the people who do the technical side. So I can't advise you what A-levels to do specifically for the space industry, but for engineering, maths and physics would be my best suggestion. And then pick some others. If you've got a variety of things you're interested in, maybe pick something contrasting.
Okay, thank you. So that's really interesting to know. So it is a really broad industry of skills and areas that you can actually go into to work within the space. Lovely. Okay. So I've got a question. Where can I find the data from the can't even say it now. Copernicus missions.
No problem. So it's actually on the European Space Agency website. You can search for Copernicus data. It comes in lots of different formats, so some of them won't be so easy for you to process, but there are some instructions about how school classes can actually look at the data and what you can find out from it. And all of that's on the European Space Agency website.
Okay, lovely. I've just popped that in the chat for everybody, the essay. It's just coming up now. And the next question, are there many women engineers working in space?
There are. There didn't used to be. It's very true. If you look back to the Apollo missions, to the early missions to the moon, there were very, very few women. But that situation's definitely improving. In my office, it's about 20% women. So we're not at 50-50, but that's okay. I find that we're really, really supported. There was a great community of female engineers when I was at university. with some, some support and some networking, just so you get to know other female engineers. But for the most part, I don't worry too much about the fact of how many women there are. It's just lots of people who are like-minded and want to do, they want to design and make things and, go to space, whether they're men or women.
Okay. Yeah, we've got lots of questions coming through, which is great. So I've got a question from Matilda. How long do you spend on a project on average?
So that depends. For me, working in Earth observation, a lot of our satellites are really complicated. And in addition to that, they're quite often all unique. So you design it from scratch and you just build one of them. And that means that the projects can take quite a long time. We can be looking at sort of 10 years from coming up with the initial designs to launch. And for someone like me who's working on payload design, I might be heavily involved in the project for about 6 to 7 years. So there's a bit of time at the end where it's already on the spacecraft and they're testing at spacecraft level. I'm not as involved then. And I might get the opportunity to go and see it launch, but I don't have to do any work towards the launch. If you're working in telecommunications, then that sort of project site life cycle time is more like 2 to 3 years. Because often you're rebuilding something with some changes from an old project. But if you're looking at some of the exploration missions or the human spaceflight, you can be looking at a 20-year project. So I would expect in my career to probably be working on about 5 projects in total, which is pretty crazy. But often you're working on a couple at a time. So it doesn't get at all boring, and it's really satisfying to see a project all the way through from start to finish.
Oh, brilliant. Okay, so I've got a question. How many satellites has Airbus launched?
Oh, I don't actually know the answer to that question. It probably is out there somewhere on the internet. But the number must be huge. We've been launching satellites, I believe, for over 50 years. And there's always different ones in build with different departments in different countries. I think it would be hundreds, but don't quote me on that.
Okay, so definitely a lot. Yes. I've got a question here. Are you paid for the apprenticeship programme?
Yes, our apprenticeships are paid. So it's kind of learning whilst you're earning money. So our apprentices join normally between sort of 16 and 19 years old, depending on what the apprenticeship is. And a lot of the schemes are sort of 3 to 5 years. And you earn money throughout, and your salary increases as you get more experience and you learn more.
Okay. Are you happy to keep going? Because we are coming towards the end, but we've still got a few questions to go.
I'm happy to answer some more questions if you've got some more there.
I've got more questions. So Addie's asked, have you found it difficult to be a woman in STEM and engineering?
I think I've been very lucky. I haven't found it difficult as a woman in this industry. I found it quite supportive. I found quite a lot of people want to see more women in this industry, and they can see a benefit to having not just more women, but more variety, more diversity in people generally within the space industry. The more variety you have in people's backgrounds and their skills and their life experience, the better their designs are, the better we can do as an industry. So most people really want that and are really supportive. It does mean occasionally I'm in a meeting where perhaps there'll be 20 people in the room and I'll be the only woman. But in all honesty, I don't notice it that much. And I think that really depends who you are as a person. For some people, it might bother them. For me, not so much. But I've also noticed that over the past 6 or 7 years, more and more of our graduates and our apprentices are women. So the industry is definitely moving towards it being more balanced from a gender perspective.
Definitely, and does mean that people that are in school at the moment, it's going to just keep going and going. So as they get towards working with the industry, I'm sure there'll be even more women by then. Okay, so I've got a question. What rockets are used to launch the satellites, and where are they launched from?
So there's quite a variety. For a lot of the European Space Agency projects, they're launched from French Guiana. We use lots of different rockets. Those can be, some of them are like the American built ones. So that could be something like a Saturn V. You could also be looking at things like Ariane, which is linked to Airbus. For some of the smaller satellites, they might be launched, like the Novastar project I worked on, that was launched from India. So lots of different places all over the world with launch facilities, and depending which ones you're using depends on what rocket you launch on. And a lot of that comes in the early design phase with a satellite or any space program. If you're sending a space probe, for example, depending what you're designing depends how big it is, how far into space it's got to go, and that gives you a choice of suitable rockets and where you might have to launch from to get to where you want to go.
Okay, so I've got a chance for just one more question. Has Airbus found any evidence of life on Mars?
I don't think we have yet. So hopefully once the Mars rover is launched, we should be able to have a better look over Mars ourselves and collect some data, some sample retrieve. But I don't think we've found life just yet.
Okay, so we have to wait 2028 for the rover to go up there. Lovely. All right, thank you so much for that, Harriet. That was really fascinating, interesting talk, and for answering those questions. And thank you to everybody who's been watching and putting the questions in the chat. And we hope you've really enjoyed it.
Thank you all for the great questions. I've really enjoyed it.